You are sitting somewhere quiet right now, maybe at your desk, maybe in your car before you walk into work, and without even thinking about it, you let out a low hum, just a few seconds of sound with your lips closed, the kind of thing you do when you are not really paying attention to yourself. Most people treat that sound as nothing, a leftover habit, background noise your body makes when it is bored. But here is what almost nobody realizes. In the 60 seconds after you start humming, your brainstem, your inner ear, your nasal cavity, and one of the longest nerves in your entire body all shift into a different operating mode, and that shift is measurable. It shows up in blood tests, in heart rhythm data, in brain scans, and in the actual chemistry moving through your skull. Today I want to walk you through exactly what happens inside your head, second by second, when you hum for 1 full minute, and by the end of this, you will understand why something this small and this ordinary might be one of the most underrated tools sitting inside your own body, a tool you have technically had access to your entire life, without ever once reading the instructions for it. Before we go further, if this kind of explanation, the actual mechanism behind something simple, is the kind of thing that keeps your attention, that is exactly what we build here at Smart Psychology. So stick around for this one, because the second half changes how you think about your own nervous system. Let's start with the nerve that runs this whole show, and that is your vagus nerve. Your vagus nerve is the longest cranial nerve in your body. It starts at the base of your brainstem and travels down through your neck, your chest, and into your abdomen, branching out to your heart, your lungs, your stomach, and your gut along the way. About 80% of the fibers in the vagus nerve are sensory, meaning they carry information from your organs up to your brain, not the other way around, which tells you something important. Your body is constantly reporting its internal state to your brain through this single pathway. Researcher Stephen Porges, who developed what is known as polyvagal theory, spent decades documenting how vagal tone, meaning how responsive and flexible your vagus nerve is, predicts everything from stress resilience to emotional regulation to how quickly you recover after something upsetting happens. People with higher vagal tone tend to calm down faster after conflict, sleep better, and show lower baseline inflammation. And here is the part that connects directly to humming. The vagus nerve runs extremely close to your vocal cords, your throat muscles, and the muscles at the back of your soft palate, which means that when you vibrate your vocal cords in a sustained low hum, you are mechanically stimulating a nerve that has direct wiring into your heart rate, your digestion, and your stress response system. Now let's talk about what is happening physically inside your nose and sinuses, because this is where one of the most interesting pieces of research comes in. In 2002, researchers John Lundberg and Eddie Weitzberg at the Karolinska Institute in Sweden published findings showing that humming dramatically increases the release of nitric oxide from your paranasal sinuses, the air-filled cavities behind your cheekbones and forehead. Their measurements showed nitric oxide levels rising by roughly 15 times compared to quiet exhalation through the nose. Nitric oxide is a signaling molecule your body uses to relax and widen blood vessels, and in your sinuses specifically, the humming vibration seems to physically shake loose nitric oxide that has been sitting trapped in that narrow connection between your sinus cavities and your nasal passage. Once that nitric oxide moves into your nasal airflow, some of it gets carried down into your lungs, where it helps relax the smooth muscle lining your airways and improves how efficiently oxygen crosses into your bloodstream. So in the first few seconds of humming, before you even reach the 1-minute mark, you have already triggered a measurable chemical release that most people go their entire lives without knowing exists. If you are finding this useful so far, this is a good moment to hit follow, because we are about to go into the part involving your brainwaves, and that section builds directly on everything I just explained. Let's move to the mechanical side of things, the actual physical vibration traveling through your skull. When you hum, the sound does not just travel outward through the air, it also travels inward through your bones, through what is called bone conduction. That vibration reaches your inner ear directly, bypassing the normal path sound takes through your eardrum. Your inner ear contains not just the cochlea, which handles hearing, but also the vestibular system, a set of fluid-filled structures responsible for your sense of balance and spatial orientation. Some researchers studying sound therapy and vocal toning have proposed that this direct bone-conducted vibration against the vestibular apparatus contributes to the calming sensation. People report almost immediately after humming, because the vestibular system has direct neural connections to brainstem regions involved in arousal and alertness. This is part of why chanting, humming, and low-frequency vocal toning have shown up independently across so many cultural and spiritual traditions for thousands of years. Long before anyone had the tools to measure nitric oxide or vagal tone, people were noticing the effect, even without understanding the mechanism. Now here is where things get really interesting. Because humming does not just affect your nose and your ears, it directly changes the rhythm of your heart. Heart rate variability, which is the tiny variation in time between each heartbeat, is one of the most widely used markers of nervous system balance in modern physiology research. Higher heart rate variability generally reflects a nervous system that can shift flexibly between alert states and calm states, while lower variability is associated with chronic stress and reduced resilience. Studies looking at Brahmari pranayama, a yogic breathing technique built almost entirely around a sustained humming exhale, have measured significant increases in heart rate variability within just a few minutes of practice, along with reductions in systolic blood pressure and self-reported anxiety scores. The mechanism researchers point to is straightforward once you understand it. A slow, extended exhale paired with vocal vibration stimulates the vagus nerve strongly enough to shift the balance of your autonomic nervous system away from sympathetic activation, which is your fight or flight branch, and toward parasympathetic activation, which is your rest and digest branch. Within roughly 30 to 60 seconds of sustained humming, many people show measurable decreases in heart rate and increases in the parasympathetic markers that researchers track using electrocardiogram data. Let's talk about your amygdala for a moment, because this is the part of your brain most directly responsible for detecting threat and generating fear responses. Your amygdala receives constant input from your body about your physiological state, and one of the strongest signals it uses to judge whether you are safe is your own heart rhythm and breathing pattern. When your breathing slows and becomes more regular, and when your heart rate variability increases, your amygdala receives a kind of internal message that things are under control, which reduces its own activation. Functional imaging studies on slow breathing and chanting practices, including research on Om chanting published in International Journal of Yoga, have shown reduced activity in limbic structures associated with emotional reactivity during and immediately after sustained vocal toning exercises. This is not a placebo effect in the sense people usually mean that phrase. The researchers are measuring actual blood flow changes in brain regions using imaging technology, and the pattern consistently points toward reduced limbic activation and increased activity in prefrontal regions associated with calm, deliberate thinking. There is also a cortisol piece to this story, and by now you already know from other things you may have seen that cortisol is your primary stress hormone, released by your adrenal glands and regulated by a feedback loop running between your brain and your body. Chronic elevation of cortisol is linked to poor sleep, impaired memory consolidation, and increased inflammation throughout your body. Small trials examining humming and chanting practices have found reductions in salivary cortisol measured after sessions as short as 5 to 10 minutes, and the proposed pathway runs through the same vagal stimulation we have already discussed. Because your vagus nerve has direct influence over the hypothalamic pituitary adrenal axis, the chain of glands responsible for producing cortisol in response to perceived stress. Stimulating the vagus nerve through humming appears to dampen this axis, which is part of why people so consistently report a felt sense of calm within roughly a minute of sustained humming, even before they understand any of the biology behind it. Before moving to brainwaves, it helps to understand why humming produces such a fast effect compared to other calming techniques people usually reach for. Slow breathing on its own without any sound does activate the vagus nerve to some degree, and this is well documented in research on box breathing and other paced breathing techniques used by clinicians and performance coaches. But humming adds 2 extra layers on top of plain slow breathing: the mechanical vibration of the vocal cords and the resonance moving through the sinus cavities and skull bones, both of which are absent from silent breathing exercises. This is likely part of why some small comparative studies looking at breathing techniques have found that vocal toning and humming produce faster subjective calming reports than matched duration silent breathing, even though both approaches ultimately work through the same underlying vagal pathway. In other words, sound is not decoration here. The vibration itself appears to be doing physiological work. There is also a developmental angle worth mentioning, because humming shows up extremely early in human life in a way that suggests it may be doing something evolutionarily important. Caregivers across essentially every documented culture hum to infants, often without any conscious awareness of why, and researchers studying infant physiology have found that humming and soft vocal toning from a caregiver measurably slows an infant heart rate and reduces cortisol reactivity during distress. Some researchers studying attachment and co-regulation, the process by which a calm nervous system helps regulate a distressed one, have proposed that this caregiver humming works through the exact same vagal and auditory pathways we have been discussing, meaning the infant-owned vagus nerve responds to the low-frequency vibration and steady rhythm coming from a caregiver chest and throat during close contact. If this pathway is old enough and important enough to be built into how infants regulate stress before they can even understand language, that tells you something about how deeply wired this response really is inside the human nervous system. Musicians and singers have also been an unintentional research population for this topic for a long time, since professional voice training frequently incorporates humming as a warm-up technique, originally for purely acoustic reasons related to vocal cord conditioning and resonance placement. Vocal coaches have observed for generations that humming before a performance also appears to reduce performance anxiety, and physiological studies on performance anxiety in musicians have found reduced heart rate and reduced self-reported anxiety scores following structured humming warm-ups compared to silent warm-up routines. This lines up precisely with everything already covered here. A performer stepping onto a stage is activating a strong sympathetic stress response, and a few minutes of low, sustained humming appears to counteract that activation through the vagal pathway before the moment that actually matters. There is also a sleep-related piece to this story that rarely gets mentioned, and it connects directly back to the vagal and cortisol mechanisms already covered. Elevated cortisol in the hours before bed is one of the most consistently documented disruptors of sleep onset, and researchers studying pre-sleep relaxation techniques have looked at short humming or chanting practices done in the 30 minutes before bed as a way of lowering evening cortisol and shifting the nervous system toward parasympathetic dominance before lying down. Some of this research overlaps with studies on memory consolidation, since deep sleep stages are when your brain does much of its work moving information from short-term storage into longer-term memory networks, and a nervous system that enters sleep already in a parasympathetic state tends to reach those deeper sleep stages more efficiently. None of this means 5 minutes of evening humming replaces good sleep hygiene, but it does add another data point to the same pattern showing up throughout this entire explanation. A small vocal behavior repeatedly nudging your physiology towards states that support recovery, rather than states that keep you running on stress chemistry. Now let's bring in brainwave activity directly, because electroencephalogram studies, which measure electrical activity across your scalp, have looked specifically at what happens during humming and chanting practices. Several small studies have found increases in alpha wave activity during sustained humming, and alpha waves are generally associated with a relaxed but alert mental state, the kind of state associated with light meditation, calm focus, and reduced mental chatter. Some of this research has also picked up shifts toward theta wave activity in certain frontal regions, theta waves being associated with deep relaxation, in some contexts with creative and associative thinking. None of this means humming is some kind of magic switch. The studies are relatively small, and researchers are honest about needing larger trials. But the direction of the signal across multiple independent studies using different populations and different measurement tools keeps pointing the same way, toward a shift from an alert, scanning brain state into a calmer, more internally focused one. There is one more chemical piece worth mentioning, and that is oxytocin, sometimes called the bonding hormone because of its role in social attachment and trust. Group chanting and communal humming, the kind that shows up in religious and cultural practices across the world, has been associated in some studies with increases in oxytocin among participants, particularly when the humming or chanting is done in synchrony with other people. Researchers studying synchronized vocalization, including work looking at choir singing and group chanting, have proposed that shared rhythmic vocal activity helps synchronize physiological states across a group, including heart rate patterns between individuals sitting near each other, a phenomenon sometimes called physiological linkage. This does not mean solo humming in your car has the same social bonding effect as group chanting, but it does show you that the same basic mechanism, vibration paired with slow controlled exhale, is doing measurable work across a surprisingly wide range of human contexts. So let's put the full 60-second timeline together now that you understand each individual piece. In the first few seconds, your vocal cords begin vibrating, and that vibration starts stimulating branches of your vagus nerve running through your throat and soft palate. Within the first 10 to 15 seconds, nitric oxide trapped in your paranasal sinuses begins releasing into your nasal airflow at levels many times higher than normal breathing, some of which reaches your lungs and begins relaxing airway smooth muscle. By 20 to 30 seconds, the extended exhale pattern required to sustain a hum begins shifting your autonomic nervous system balance, nudging you away from sympathetic dominance and toward parasympathetic activity, and your heart rate variability begins climbing. Around the 30 to 45 second mark, your amygdala is receiving updated signals from your slowing heart rhythm and steady breath pattern, reducing its own activation and easing the felt sense of alertness or tension you may have been carrying. By the time you reach the full 60-second mark, measurable shifts in alpha wave activity have begun showing up in electroencephalogram recordings in research settings. Cortisol release through your hypothalamic pituitary adrenal axis has been dampened, and if you are humming near another person, early physiological synchronization may already be starting to form between the two of you, meaning both nervous systems settling into a calmer rhythm together, rather than separately. If any part of this made you think differently about something as small as humming, that is really the whole purpose of this channel, taking ordinary behaviors most people never question and showing you the actual machinery running underneath them. So if that is useful to you, following along means you will not miss the next one. There is a practical piece worth mentioning before we close, because understanding the mechanism only matters if you can actually use it. Researchers studying Bhramari pranayama typically describe the technique as closing your lips gently, placing your fingers lightly over your ears if you want to intensify the sensation, taking a slow breath in through your nose, and then humming steadily through a long exhale, repeating this for several rounds rather than a single breath. The nitric oxide research from the Karolinska group specifically noted that humming produced far higher nasal nitric oxide levels than quiet nasal breathing, which suggests that the sustained, resonant quality of an actual hum matters more than simply exhaling slowly without sound. People dealing with mild tinnitus have also reported some symptom relief from regular humming practice, and while the research here is still limited, the proposed connection runs through improved blood flow and vagal regulation affecting structures in the inner ear. Most of the small clinical trials in this space use session somewhere between 5 and 15 minutes, several times per week, rather than a single 60-second burst, and researchers studying Bhramari specifically have noted that consistency over days and weeks produces more stable heart rate variability improvements than a single isolated session, which lines up with what we generally know about autonomic nervous system training in other contexts as well. That said, the 60-second window we have walked through today is not arbitrary. It appears to be roughly the amount of time needed for the earliest measurable shifts, the nitric oxide release, the initial heart rate variability change, and the beginning of amygdala down-regulation to actually register, which is exactly why so many people report an almost immediate felt sense of relief, even from a single short round of humming, before they have any idea what is happening underneath it. Think about how many moments in an ordinary week actually call for exactly this kind of tool. Sitting in traffic before a difficult meeting, standing outside a door you are nervous to walk through, lying awake with your mind still running through the day, waiting on a phone call you have been dreading. In almost every one of those situations, people who reach for their phone or a coffee or nothing at all, simply tolerating the tension until it passes on its own. What the research covered today points toward is a genuinely available alternative sitting inside your own throat and chest, something requiring no download, no subscription, and no special training beyond closing your mouth and letting a low, steady tone come out for about as long as it takes to boil an egg for 1 minute. What makes all of this worth paying attention to is not that humming is some undiscovered miracle. It is that your body has been carrying a genuinely useful regulatory tool this entire time, built directly into something as ordinary as the sound you make without thinking about it while doing dishes or sitting in traffic. Your vagus nerve, your paranasal sinuses, your inner ear, your heart rhythm, and your own brainwaves are all wired together in a way that responds to something you can do anywhere, with no equipment, no app, and no cost, in under 60 seconds. None of the mechanisms covered here require you to believe anything on faith. They are drawn from measurable data collected in labs, studying nitric oxide chemistry, cardiac rhythm, cortisol assays, and brainwave recordings, which is exactly the kind of grounded explanation this channel tries to bring you every time. The next time you catch yourself humming without meaning to, or the next time you are feeling wound up before a stressful conversation or a big moment, you now know there is real physiology behind trying it deliberately, a nerve pathway, a chemical release, a shift in your heart rhythm, and a brain slowly being told that it is safe to come down from high alert. That is the actual story behind 60 seconds of humming, not a trick, not a piece of folklore, but a set of measurable biological events happening in your own head every time you do it, quietly running in the background of an ordinary day, waiting for you to actually notice it.